case study, we're discussing about one simple numerical problem that is called as constant strain triangle method. Okay. So first of all, what is meaning of DST? It's called as the constant strain triangle element. So what is the difference between constant strain triangle element and LST? Okay. So the constant triangle element it having a 6 degree of displacement. When calculating the problem. So whenever you are solving the numerical problem, we have to find out the safe function under corresponding to the interior point of the given problem. So first numerical problem we're discussing to determine the safe function n1, n2, and n3, the interior point V of the triangle element as shown in figure. And the second numerical problem we are discussing in class also. So that problem is called as the nodal coordinate triangle element as shown in figure at the interior point of P. It is having x coordinate 3.5 and the n1 0.4 and calculate n2 and n3 and also find out the y coordinate. So the first numerical problem, if you use the shape function, you have to find out the x and y coordinate. In second numerical problem, we discussing about we given the x coordinates and remaining n1 also given. You have to find out the n2 and the n3 and y coordinate. So our students that will be explain these two problems in upcoming session. Thank you.
Today I will discuss about problem is not binary element analysis about shape function. Okay, this is the problem. This is the problem. Determine the shape function n1, n2, and n3 at the interior point P for the triangular element shown in this figure. This is the question. Okay, this is x1, x2, sorry, y1, x2, y2, x3, y3. We know that x1 equal to 2, x2 equal to 7, x3 equal to 4. Okay. Uh, y1, uh, y1 equal to 3, y2 equal to 4, y3 equal to 7. In shape function, we have to find the n1, n2, n3. Before that, we know the condition x equal to x minus x3 into n1 plus x2 minus x3 into n2 plus x3. Y equal to y1 minus y3 into n1 plus y2 minus y3 into n2 plus y3. This is the equation for to find the n1, n2, n3. Substitute the coordinated values. We know that x equal to 3.5. To substitute these values according to the uh, next, the 3.5 equal to minus 2n, this value plus 3n2 plus 4. Okay. Next, after the substitution, we have 2n1 minus 3n2 equal to 0.5. This is the equation number 1. And second one is y. Y equal to minus 4n1 minus 3n2 plus 7. Okay. After the solve this equation, we have 4n1 plus 3n2 equal to 2. This one is equation number 2. We have to solve this equation for finding n1, n2, n3. We get n1 equal to 0.4116, n2 equal to 0.111. Next, we have to substitute n1, n2 value in this above equation. n1, n plus n2 plus n3 equal to 1. After the substitution, we get n3 value. That's all. Next, we see another problem. The nodal coordinate of the triangular element are shown in this figure at the interior point P. The x coordinate is 3.5 and n1 equal to 0.4. Calculate n2, n3 and the y coordinate at the P. Okay. These are the given data from this diagram. To find shape function n2 n3 and the coordinate y. Okay, we know that the shape function in equal to 1. Yeah, we already know that equation n1 plus n2 plus n3 equal to 1. Substitute the equation according to the given data. Uh, we know n1 0.4 plus n2 plus n3 equal to 1. N2, n3 we don't know, but we know 0.4. To solve this equation, we get n2 plus n3 equal to 0.6. Take this is equation number 1. Coordinate x equal to, we know that this formula, n1 x1 plus n2 x2 plus n3 x3. We know x value, that is 3.5. N1 value 0.4, x1 value 1 plus n2 x2 value is 4 plus n3. We don't know n2 and n3. So write as well. X3 equal to 6. So we written it. Next, substitute this equation, we get 4n2 plus 6n3 equal to 3.1. This is equation number 2. Solve this equation, I mean 1 and 2. We get n3 equal to 0.35, n2 equal to 0.25. Next, we need to substitute the coordinate equation y equal to n1. Already we substituted x coordinate, and then we have to substitute the y coordinate. Axis y equal to n1 y1 plus n2 y2 plus n3 y3. N1 value we already knew it. Y1 also we know it. 0.25 into 3, 0.35, yeah, this value. Finally we get y value, that is 2.95. Okay, that's all. Thank you.